The best thing about Z is anything you ever wrote still works. And I will admit, the worst thing about Z is anything you ever wrote still works.
Ever wonder what's really powering some of today's most complex systems? One word: mainframe. And though mainframe technology has been around since the 1950s, they're not relics of the past. These days, they're the AI-ready nerve center of many modern organizations. Today, we're going to dive into this critical organ for over 70% of Fortune 500 enterprises and their AI power you might be overlooking, and two women behind the technology who are making it happen. I am thrilled to be joined by two mainframe experts and trailblazers, Donna Dillenberger, IBM Fellow and CTO of Hybrid Cloud Systems Research, as well as Rosalind Radcliffe, IBM Fellow and CTO for IBM CIO Platform Transformation. Welcome, Donna and Rosalind. Now, can you tell us about you and how you got into this industry? Why don't I start with you, Donna?
You might think I was born to be in this industry, right? My parents, they didn't have a lot of spare money to pay for toys. And so my brothers and sisters, anything that we wanted to play with, we had to build. We built our own cars with rubber bands and tissues and buttons, tissue boxes. We built our own forts with blankets and chopsticks. We'd rather build things than buy them. And so in high school, I actually started working on my first mainframe. And it was really interesting because that mainframe was physically in IBM Research in Yorktown Heights. My high school was in Brooklyn, in Brighton Beach, and we would use a modem and punch cards to send programs to IBM Research on a mainframe. In college, what happened was I was majoring in math. A recruiter from IBM came when I was a junior, and the recruiter said that if I joined IBM, they would pay for my graduate school tuition and my books, and they would give me a salary, while I was studying. And that seemed perfect. And so I joined IBM right out of college. And the group that recruited me at IBM was the mainframe group. And now I have to say, all these years later, I'm at IBM Research in Yorktown Heights, where my high school mainframe was. And I run the mainframe group in IBM Yorktown Heights. And it wasn't a deliberate plan. It just happened that way. It's almost like karma or fate. So that's how I got into it. It's weird.
You have a complete loop right there.
It's a circle. It's like a virtuous circle.
Wow.
Yeah. Things don't always happen by chance.
Mm-hmm. So Rosalind, is your connection to the mainframe also such a complete circle?
Definitely not so circular-ish. There's no reason I shouldn't have ended up in computers or in the mainframe at all, because my background, my father was an English professor of medieval studies. My mom was a elementary school, middle school teacher. So there was no technology when I was growing up. There weren't computers. So when I went to college, I had done some things in high school with computers, playing with we actually did have a mainframe. Now that I figured out what it was, that teletype machine, it was actually a mainframe in the background. Not that I knew it at the time. But when I got to college, I decided the easiest degree, nobody would like this, was computer science. It wasn't, but it was fun. So it was easiest, in my opinion. And so when I was graduating, I got a job with IBM. And I started in ISPF development. And I had no idea what that was, but that's all right. I learned, I had fun, and I've been in and around the mainframe in IBM ever since. And it's a great opportunity, and it's fun. I actually just moved back to the Z org again, so, stay around Z.
I want to take a brief step back because we are talking about the mainframe. But Donna, can you help us understand what exactly is a mainframe? What is a Z, and why are they important?
Mainframe, IBM Z, Linux One, they're three names of the same architecture. And the architecture is of this extremely powerful computer box. As you said in the beginning, a mainframe, we started with the System 360 system. And I would say even, it descended from like the 1950s, the architecture there. And the thing about it is Thomas Watson Jr. from IBM, he decided in the 1960s that all the systems that IBM would develop would be interoperable. They would work with each other, the whole 360 architecture. And since then, from the 1960s all the way now, any program that you write on a mainframe, even from the 1960s, is going to work on today's present day mainframes. Not only will they work, but they will run faster, and they'll run with better security. They'll run with less electricity, and without changing your code. So it's almost like, how today we always change our laptops every 2 years. We change our phones every 2 or 3 years. And, you have to always move the data. On a mainframe, your programs, if you want, could stay the same. It'll work. It's like your phone today would be working in the year 2100, and all your favorite apps, they would still be there. Nothing would be deprecated. And as the years go by, it takes less electricity to run that. So you might start with this one car, and it would require 10 gallons of gas. And now, as the years go by, it just requires a 10-volt battery,
Sure.
And so it's a really powerful computer system. And, it runs, not only the original operating system, but it runs Linux right now. And as new technology comes, it finds a way to make that technology faster, more secure, and require less electricity, like AI. So
Okay,
that's how I would describe it.
You've really hyped up this mainframe
It's
over
not
here.
It's real.
This
It's real. Yeah, it works on it. It's amazing.
Rosalind, I need you to back Donna up, though. Please tell me more about how this is actually real. How does it do all these things that Donna claims that it does?
It does. I mean, the advantage of the mainframe is we build the hardware to be sustainable, to be highly available, to be able to run the high transaction throughput, guaranteed reliability loads that we need. So when you think about a mainframe, in a sense, it's a cloud in a box. I know some people don't like that, but I don't care. It's a cloud in a box. It allows you to run very efficiently high transaction loads, guaranteed reliability, always consistent data. And it can do it because the hardware is built so that you can run at 8 nines. Think about 8 nines, and I always do the math wrong, but it's less than a second. It's 0.3 something of a second, a year of downtime, which means it's always available. Basically, most people configure Z's in configurations that mean it's always available. And if you need to do a credit card transaction, you need it always available. And so it's really handy to have the system that can handle all of the credit card transactions, and it can keep the data consistent, and you don't have to worry about crashing. And so, yes, it's really true. The best thing about Z is anything you ever wrote still works. And I will admit, the worst thing about Z is anything you ever wrote still works. Because it just works. It keeps working. So you don't necessarily update your applications. The hardware itself continually is updated. Advancements, continuous advancement. And you kind of look at it, it's the most modern machine in the world.
Rosalind has just reminded me of something, that IBM Z, we call it an IBM Z. Z's for zero downtime. It's never down. We have customers that have never restarted their system in 15 years. Yeah, I know. I mean, look at all the times you have to restart your phone or restart your laptop. 15 years because they can't afford to, right? Because their operations require it always to be up. We have an option. If you buy a new mainframe, you could take parts of your old mainframe out. You could take out the processors, the memory, and it would still be running. And you could put the new parts in, and it would still be running. That's what zero downtime means.
Zero downtime.
Yeah.
But how is it that these applications don't need to be updated whatsoever, though?
Because of the compatibility that's there in the system, the guaranteed compatibility at the operating system level, we ensure that things that you wrote will just keep running. And that's why I said it's the best thing and the worst thing, because that means you have to support everything that was working and keep supporting it. And so it's really a trick there. One of the reasons why that works, and one of the reasons you look at a mainframe, is it scales up. So I'm scaling up my system so I can process things better. I can process them more efficiently. I can all the data together, unlike in smaller systems where you're scaling out. And by scaling out, you have to shard your data, you have to split up things, you have to do extra work to try and bring it all together to then get your solution. The value in the system is I can scale as up in ways you can't anywhere else. And that's why you're so much more efficient. There have been so many sets of let's move all this work into the system because then I can be more efficient. I can be more cost effective. And now, especially with AI, being able to do work with AI on the machine, it's where the data is, it's where the transaction is running, and it's more energy efficient. We get sustainability and complete fraud detection in a sense. I can run it on every transaction instead of just some transactions. It's a really big win by being able to scale up and have the ability to do it all together.
Before a smartphone, a person would have a camera, a phone, another device to listen to music, another device to like play video games, another device to like keep track of like train schedules or something. And they might have like all these different little boxes that they had to carry around in a purse, at least
A
that's what
GPS
women
system.
use.
Yeah. Uh-huh.
And then it all consolidated into like a smartphone. The mainframe is like a smartphone for servers. Before the mainframe, right? I mean, before a mainframe, you'd have to have a separate box just for this application, another computer box for fraud, another computer box for medical diagnosis, another computer box for supply chain or banking or transactions. But because of the architecture of the mainframe, it consolidated all into one box.
That consolidation is making me think about sustainability. So can we talk a little bit more about that sustainability element, especially when considering the mainframe, and also why it's important? Like, why does it matter?
It is really important that we look at the power consumption for our actual business work. From a business standpoint, businesses have sustainability goals. They have carbon neutral goals or net neutral goals, whatever they are. They have to meet those. And in Europe, it's even more significant that they're driving to this energy reduction with regulation, with lots of controls, and the cost of energy is high. And so by reducing my energy footprint, by being much more efficient in how I do all my processing, I can more easily meet my sustainability goals. And then it's not my computer that I'm having to worry about. It's everything else people are doing, like getting on planes. And that's a challenge that's harder to deal with. But you can reduce the IT footprint significantly, and which really helps our sustainability goals and helps our environment.
Okay, so in the AI era, how are AI and mainframes now working together? And how do you see that continuing to evolve in the future?
AI of today, which includes machine learning, right? It uses math to find patterns in data. And, math like matrix operations, tensor operations, which is just a way of doing arithmetic on many numbers simultaneously. You could do that a normal way that a calculator does it, or you could build special hardware to do that so that it's really fast. But not only in the mainframe do we have AI accelerators to do that type of math for AI, but we built those accelerators to also be extremely energy efficient. So we have AI accelerators in the mainframe built on like our Telum 1 chip. So that AI accelerator is right on the core. When I say core, a processor core. And that's really important because the data goes through a processor core. And normally what you have in other AI accelerators is that, okay, now we have to move the data from this processor to the AI accelerator. And as Rosalind said, that's going to require more latency. So it's going to take more time to go through all these like financial payments and transactions. It's going to require more electricity. And when that happens, some of our customers told us they can't keep up with like trying to check if all of these payments are fraudulent or not, if someone's trying to steal money out of your checking account. But if you have an AI accelerator right on the core, so you don't have to copy the data, you don't have to move the data. Instead, you get like, as I said before, 32 million inferences per second. Then now these companies, instead of like saying, okay, we're only going to check every 100th payment, they now could check every payment to protect your money. And so that's one type of accelerator. The other type of accelerator we're providing is called the Spire card. And a Spire card not only has that one AI accelerator, now you have 32 of those AI accelerators in one card. And you could put 48 cards in an IBM Z system. And if you need more than that, it could fit like 96 cards.
My goodness.
So you even have like more scalability to do AI. And that's just the hardware. The software part is, we're writing all this firmware to dynamically move the software to the AI accelerators that could like service it. So one reason why, GPU systems and smaller systems require so much electricity is because they're always on. They're waiting for AI workloads to come to them. And there's no efficient way to like always keep them busy. But the mainframe excels at like what we call virtualization, making sure that all of the processors are busy all the time. So it's almost like in this building, right? I'm guessing, maybe there's like 80 people in this building, and they have to get to places. And how it's normally done to get to places, say there's no trains here, but they would have 80 cars, 80 Ubers constantly circling around the block, waiting for someone to hop on. Even if I'm here for like 5 hours, there'd be an Uber just waiting for me, extremely inefficient.
Very.
Right? So what the mainframe version of that is that we have one Uber and we have a really intelligent scheduler. And that intelligent scheduler says, okay, I'm going to go somewhere, at 5 p.m. Albert is going to go somewhere at like 6 p.m. And that efficient scheduler knows to bring that car back, so we could reuse as few Ubers as possible or as few cars. Right. So that's what's missing from the other systems, but that's built into the AI mainframe and the software stack.
Are there some AI workflows happening that should be moving to Z that aren't there yet?
Oh, inference workloads should go to Z. Inference workloads that require Linux, they should try going into Z, especially any workloads where the data is already on a Z system. It just makes sense to bring the models to the data.
Well, I want to spotlight the two of you for a second. This is still a male-dominated field. How has the experience been for you, and what would you say to women who might be thinking about this path?
I think I've been very lucky, and it might just be my era. When I was in college, I didn't know what to major in. I really liked school. So I asked my father, what I should major in. At one point I thought I wanted to be a musician, a writer, an artist, right? But I liked the STEM subjects as well. And he heard me talk about all of the courses I took. And he never saw a computer, in his whole lifetime. But I think just by the way I describe my computer classes, he says, major in computers, right? I didn't even know it. He just thought I would enjoy it that well. And he said another reason why you would enjoy it is because it's based on things that people could measure, right? They could measure how fast your program is. They could measure how concise it is. Whereas other things might be a little bit more subjective. It might be based on, the clothes you wear or something. So, I didn't know anything at that time. So then I got to IBM, and it was just like he said. I was the youngest person in my department. It was a hardware simulation group. I was the only Asian person. I really liked coding. I could code all day, all night. It was just so fun. And, I would do 50,000 lines of assembler code in just 2 months. That's how much I liked it. And after a while, my colleagues who were older, and they were men, they forgot what I looked like. They forgot my age. They said, wow, how did you do that? When my program, was able to like achieve these speeds, says, how did you do that without any locks? And I would explain it. And I think our field, at least my experience, it was very objective. And then, I have colleagues like Rosalind, and there were other women who are just as accomplished as Rosalind. And so there was always people I could look to, and I said, I want to be like her.
I think we are in many ways lucky because IBM has been a better company than a lot of other places. I have spent a lot of time in services and a lot of time working with a lot of client companies and doing some things that were completely male-dominated. And IBM has been, thankfully, mostly a very convenient place to find other women who were leaders, who you could look to, who you could have conversations with, who you could understand from. If you're young and in the field, put the blinders on and say, no, I'm I'm 1 year in the company or I'm whatever. I'm not expected to know what somebody who's got 30 years in the company knows, but I am expected to know what I know. And I will be contributing with what I can do and to find support from others so that they can see that there are opportunities and use your network. And I think that's the key for any career, no matter who you are. Your network, it's who knows you, who you've worked with. That really matters, and grow your network.
I think this is a great field for young people, no matter what, when you started. When I started and I was the youngest person in the department, and we were talking before, there's a spark in everybody, right? And what makes you light up. And so when you're in a room full of people who are 20, 30 years older than you, and they put something on the board, and as a young person, you've just come with a computer science degree, the latest math and theory behind it. And what they put on the board, you forget who you are. And the geek in you comes out and says, no, we could do it this way. And you forget yourself. You forget what you were. And says, no, this is a better way. Not just IBM, but in our field, all of us, we start out as secret geeks, and some of us are maybe obvious geeks, and we're proud of it because, like you said, technology is wonderful. Being in a field or a place where you could just it's very Buddhist. It's like you strip away, the outer layers, the body, and it's only the geek in you, the essence of it, the technology. We're building something, and that makes you forget who you are. It makes you forget you're shy. Makes you forget the Asian culture, only the older people are supposed to talk first. She says, no, this is the algorithm, right? If everyone could get into that spark, whatever it is, like gardening or making beautiful, videos or art, that lets everyone just get out of their outward persona and be who they truly are.
That sounds like a beautiful mantra, get into the spark. So what other advice do you have for some women who are watching or listening to this right now who do want to break into the industry, who do want to get their spark?
If you love math, numbers, science, this is the industry to be in. I mean, creating new AI models, and once you're in AI, helping banks, helping healthcare, helping the government, helping the world. This is one of the best fields ever because it's always changing, and you always have to learn new stuff.
I think that's true. You need to find your spark. You need to find where and what makes you happy, because the happier you are, the better you'll be, and the better you'll perform for your company. And I absolutely think IT is a great place to work. You just have to understand that it is an environment of continuous learning. It is an environment of, you always have to be paying attention to what's coming out, what can I learn from it? And maybe some of the things that fail along the way, well, that's okay too. Learn from failure, experiment. And so anyone getting into this field, understand things are not going to work, learn from those, and go on, and find that funness in everything you do. Find that opportunity to innovate, to learn something new.
How does mentorship play a role in that continuous learning environment?
I mean, at IBM, there's an expert on everything, you want to learn about quantum systems? I just have to walk down the hall, and there's the person who wrote the seminal paper on quantum computing. I wanted to use AI to identify bacteria. I could go one floor up, and there's a biologist that will help me grow bacteria culture so that, we could build AI models to recognize them. And that was really fun too, because you get so into building these bacteria, you see they're happy if you give them this amount of food, and they're kind of sad when it's cold, and so you start trying to nurture the bacteria. But you see, all of us are like that. Whatever we learn, we get deeply into. So mentorship, it's if there's ever a problem, it's almost like the human virtuous circle. Someone has experienced that problem before, right? And the good thing about us is the industry is also changing and growing.
The other thing about mentoring is that most people are willing and interested in mentoring because actually it helps the mentor as much as it helps the mentee. So I learn from newer people the things that they learned in college. So I understand more about what they're learning now to help understand what they aren't learning now, which actually matters a lot. A mentor-mentee relationship is great in both sides, and I think that's a really important thing to recognize. And most people are happy to work with, especially the next generation, to say, especially when we get as old as I am, someday I'm going to want to retire, and that day isn't that far away. I mean, it's not yet, definitely, but it's not that far away. So I need to make sure there are enough people who are passionate about the mainframe so that the financial industry keeps running.
I prefer to talk to you now as opposed to like having some program ask me questions. I'd rather, and this is a true story, I'd rather call up Rosalind and ask her about some financial application, which, she's had a lot of experience with, than read about it in a book, right? Because it's just more fun to interact with experts, right? Because they tell us stuff that I would never even think of asking.
Wow, I love this symbiotic loop of learning, this continuous learning. This has really been hugely insightful, though, and incredibly interesting. So, Donna, Rosalind, thank you so much again. And to those of you who are listening, please stay tuned for more episodes very soon.